Hi, Chris Guzmal here. We're talking about formal logic and we're introducing the Fitch rules of inference. The Fitch rules are a set of 10 rules of inference that are used for a lot of logic work. The 10 are divided into 5 pairs, and we're going to go through them right now. The first rule of inference under Fitch is called and introduction. When we have two logical sentences, then we can put an and between them, and that is also a legitimate logical sentence that is entailed by the other two. There's a truth table here, where we highlight in blue that it is the case that when the two logical sentences are true, then the and of them is true. The conjunction of them is true. This one is pretty intuitively straightforward. And elimination is also very straightforward, but actually there's a little bit of a surprise here. It feels like you're not doing anything, but what we're able to do is we're able to get rid of a portion of the logical sentence, and what is entailed from the conjunction is indeed any one of the conjuncts, as it's called. The truth table that we used before applies equally, whether we read it from left to right or right to left, as the previous slide. The next rule of inference in the Fitch system is or introduction. In this situation, what we're saying is if we have a logical sentence, then we can slap any other logical sentence next to it as long as it's connected using the disjunction operator. And the truth table is actually a little bit hard to write. You can basically have a column that corresponds to psi here, and whenever it's true, then when it is ORed with anything else, what is there is still true. And that makes it so that psi entails psi or anything else as represented by the character here, phi. The next rule of inference is or elimination. You'll notice we did and introduction and elimination, or introduction or elimination. There's a pattern here. But or elimination is perhaps our least intuitively obvious rule of inference. What we're saying is that if we have something of the form Q entails R, or excuse me, Q implies R, and something of the form P implies R, then if we also have both, we have P or Q true, then that entails R. So so R is always true when P implies R, Q implies R, plus P or Q being true. And the truth table here helps make that clear. We have a truth table that is driven by P, Q, and R in the usual way. We iterate through all 8 of the possible truth values for P, Q, and R over here on the left 3 columns. And then each of these columns is the truth table, the truth column corresponding to the logical sentence with the truth assignment given. And in the situation where P implies R and Q implies R and P or Q is true, those are the situations that are highlighted in green down here in the lower right-hand corner. And we see that R is true in all 3 of those circumstances. So the or elimination rule formalizes that and generalizes that. Negation introduction is a situation where if you have something that implies one thing and it implies the opposite, then we can conclude that that thing is actually not true, or conclude the negation of that. And a truth table, such as we set up before, helps us understand this as well. Here we have a truth table where we're considering all the truth assignments for P and Q, and we then have the logical sentences of not Q, P implies Q, P implies not Q, and not P. And we see in the situation where P implies Q is true and P implies not Q is true, then in that situation is exactly the situation where not P is true. In our next part of our slide presentation, we'll talk about negation, elimination, implication, introduction, and elimination, and that will be it. Actually, we'll talk about negation, elimination, biconditional introduction, biconditional elimination, as well as implication, introduction.